This video is going to demonstrate the basic operation of my solar tracking project, and that basic operation is primarily controlled by these four photoresistors, each of which is placed in one of the four quadrants on an XY or Cartesian coordinate system. And here's the circuit basically that I'm going to show you, which is this diagram right here. And as you can see, each one of these four photoresistors is placed in series with a 1 kilo ohm resistor, and an analog input is fed into the Arduino. Now what happens is, as light alters the resistance of these four photoresistors, a different voltage will develop across the 1 kilo ohm resistor, and therefore a different analog value will be delivered to the Arduino. Now what our code that we wrote, which is written into an Arduino Uno, what that basically does is take the difference between averages. We took the difference between the average of the top versus the bottom photoresistors and the average, or the difference between the average of the left versus the right photoresistors, and then we used that code to use if-else statements and basically send signals out to a vertical and horizontal servo motor, which will adjust and move the solar panel until all four photoresistors have equal amounts of light on all sides. In addition, we also wrote code which represents the angle and the voltage being supplied by the solar panel. Now we're in the northern hemisphere, and basically the sun's always going to appear to rise and go from southeast to southwest. If you were at the Tropic of Cancer at noon on the summer solstice, then the sun would be directly overhead, but we're farther north than that, so even though during the summer the sun technically rises slightly in the northeast and sets in the northwest, it'll always be southeast to southwest for us. So now I'll basically show you how this guy works, or show you the operation of it. I'm using a desk lamp to make the motors turn. And it appears that the delay time is kind of slow, but you have to keep in mind that the sun only moves 15 degrees an hour, so there's really no need to have it move much quicker than it is. Now the vertical servo's taken into effect, and it'll come to a stop as soon as there's equal amount of light hitting all four photoresistors, which in this case is right now. I'll have it move back the other way, and once again it'll come to a stop as equal amount of light is hitting all four photoresistors. And I'll show you a little bit more of the vertical action. And I think that just about shows the basic operation of this project. Thanks for watching.